Good afternoon, my dear students. Welcome back. So today the time is 2:21 and we are recording the lecture number 10. You are watching this video on my YouTube platform Govind Chemistry and I am your chemistry mentor Govind Sir. Today the topic is enthalpy of formation. Enthalpy of formation. So what is enthalpy of formation, children? Amount of heat absorbed or released when one mole of a compound is formed by its constituent elements in their free natural state. That amount of heat is called enthalpy of formation. Like example, H2 plus O2, it is forming H2O gas. This is also gas and this is also gas. So tell me one thing, children, how to balance? It is not balance. So H2 2. So here 2 and here you can write 2 and here 4, but that pattern will be wrong. Like this we cannot do. Why cannot do? Because the thing is we have to form 1 mole. So that H2O 1 mole is already formed. Here you cannot change and here it will be half O2. Now it is balance. In that case, what is the enthalpy of reaction? Delta H is equal to delta HP minus delta HR. HP means product, enthalpy of product minus enthalpy of reactant. So in that case, product is what? Water. So enthalpy of H2O, and reactant, they all are in free naturally occurring state. Then here it will be, for hydrogen and oxygen, its value will be 0. So that is the delta H for reaction. So here this delta H for reaction, enthalpy for hydrogen, enthalpy for water, once again check it. So here the delta H is what? Enthalpy of reaction is equal to enthalpy of water minus 0. So enthalpy of reaction, in that case enthalpy of reaction is equal to enthalpy of formation also in this process. So here that enthalpy of reaction is equal to the enthalpy of formation of water. Okay, that is the concept. And the condition is what? Standard condition. Standard condition means temperature is 25 degrees Celsius and pressure is 1 atm pressure. That is the standard condition. Second example you can take, like carbon and oxygen, they are forming CO2. So what is the enthalpy of reaction, children? Enthalpy of reaction, enthalpy of product minus enthalpy of reactant. So that enthalpy of reaction will be enthalpy of formation also. Enthalpy of formation, that will be standard enthalpy of formation. Okay, what it will be? Standard enthalpy of formation. Here also it is standard enthalpy of formation of water. So here it will be what? Product is what? CO2. So enthalpy of CO2, reactant in naturally occurring state 0. Okay, in that reaction delta H is given. Delta H is equal to minus 400 kilojoule. So here standard enthalpy of formation for CO2, that will be minus 400 kilojoule. That enthalpy of formation, it is for what? Carbon dioxide. Similarly, another example, H2 gas, Cl2 gas, and here they are forming 2 HCl. In that case, enthalpy of reaction is given minus 40 kilocalorie. So delta H for reaction, delta HP minus reactant. So here it is 44 is equal to, product is what, 2 HCl, enthalpy of 2 HCl minus 0. So it will be 22 kilocalorie enthalpy of HCl. So enthalpy of formation of HCl, what? Enthalpy of formation of HCl, that will be minus 22 kilocalorie, because here 2 moles are formed, and enthalpy of formation is what? For formation of 1 mole. That is the concept. Here you can make a note, 500 rupees note. What is the note? Note is how much amount of energy release, that means delta HF, enthalpy of formation, delta HF, how much negative, how much delta HF, how much negative, that much compound will be stable, that much stable. Suppose 4 options are given and enthalpy of formation is given. So which is having more negative enthalpy of formation, that compound will be more stable. Why? Because it is releasing more energy, and if the system is releasing more energy in the whole universe, if the system is having less energy, that time only that will be the stable state. So which is losing more energy, more negative value enthalpy of formation, that will be more stable state. It is for what? Exothermic, because in the exothermic reaction only energy released. Okay, so that is it about the enthalpy of formation. Like here, like it is given, then one reaction is given, A plus 3B, it is 2C plus D. So what is delta H here? H of product, enthalpy of product, enthalpy of reactant. How to find for this? Delta H is equal to 2 into enthalpy of formation for C plus enthalpy of formation for D minus enthalpy of formation for A plus 2 into 3, so B 3 into enthalpy of formation for B. Like that we will calculate. So we will solve some problem. Question number 1. What is the question given? CH4 gas plus 2O2 gas. From here it is forming CO2 gas plus 2H2O liquid, and they have given delta HF, enthalpy of formation for CH4, it is minus 80 kilojoule per mole. Now all the unit will be same, I am not going to write. CO2 minus 400, same, and H2O minus 300 same unit. So what is the enthalpy? The question is find the enthalpy of reaction. So what is the formula? Delta H is equal to delta HP minus delta HR. So product CO2 and this is H2O. So it will be minus 400 CO2, 400 plus 2 into minus 300 product side, then reactant what we are having, this is O2 free elemental state. For this it is will be 0, so it will be minus 80 and plus 0. So here it will be minus 400 minus 600 plus 80. So what will be the answer? Minus 920 kilojoule. That is the enthalpy in this case. One more question. Question number 2. The heat of formation of NH4 NO3 solid state 400 kilojoule and those of N2O is equal to plus 80 kilojoule and H2O liquid, that is minus 300 kilojoule, and reaction is given NH4 this, and calculate delta H and delta U for the given reaction. Okay, no problem. So delta H is equal to delta HP minus HR. So product is what? Both energy is given. So plus 80 plus 2 into minus 300 minus 400. So it will be 80 minus 600 plus 400. So it will be minus 120 kilojoule. So that is the delta H here. Okay, in that case delta H we find. Now what is the relation? Delta H is equal to delta U plus delta NGRT. We have to apply this formula. Delta NG is equal to what? Product 1. So 1 only, reactant 0. 1 minus 0, it will be 1 only. So here you can solve 120 kilojoule is equal to delta U plus 1 into 8.314, temperature 298 Kelvin. Okay, because temperature is not given in the reaction, then room temperature, and it is divided by 1000 because that value in joule. So when you will solve this, your answer will come. From here you can find out delta U. I am not finding, you have to find. So that is it about the enthalpy of formation. Now the next topic is enthalpy of combustion. So during the combustion, children, what happened? Only energy release, not absorb. So what will be the definition in that case? The definition is amount of heat released when 1 mole of a compound is combusted in excess of air. Air means what? O2. So that is the definition. Amount of heat released when 1 mole of compound combusted in excess of air. That is the enthalpy of combustion. Like CH4, methane, 2O2, it will form CO2 plus 2H2O. So 1 mole methane is combusted and delta HR, enthalpy of reaction, is minus 890 kilojoule. So here that HR is equal to enthalpy of combustion. The HR is equal to enthalpy of combustion because here methane is 1 mole. Okay. Next example, like gaseous state plus 7O2, it is again 4CO2, 6H2O, and enthalpy is given minus 750 kilocalorie. So children, here 2 moles are burned. So what is the enthalpy of combustion? Half. Enthalpy of combustion 750 by 2, because enthalpy of combustion is for 1 mole. That's it about the enthalpy of combustion. At the same time, a small topic that is called calorific value. Calorific value. What is calorific value, children? It is for which, means from this value, which fuel is better. Which fuel is better, that you will identify in the case of energy released. In the case of energy release, or you can say amount of energy released by 1 gram fuel. It is the amount of energy released by 1 gram of fuel. Like given enthalpy of combustion of methane is minus 900 kilojoule per mole, and enthalpy of combustion of butane is minus 3000 kilojoule per mole. Which one is better fuel? So according to you, you can say that this, but it is wrong, because we have to check for 1 mole. Okay, so check it how. Like CH4, like 1 mole CH4 is producing minus 900 kilojoule energy. So CH4 means what? 16 gram. 16 gram CH4 is producing minus 900 kilojoule. So 1 gram CH4, how much it will produce? minus 900 upon 16, minus 900 upon 16. Okay, so it will be around calculate it. Similarly, 1 mole C4H10 release 3000 kilojoule, so it is 58 gram. It will release, then 1 gram will release 3000 upon 58. 3000 upon, it is not visible, so here it will be 3000 upon 58. So I hope this value is more. This, in the case of methane, this value will be more, this value will be less. So here it is a good fuel. The thing is, 1 gram of fuel, how much energy producing? On that basis we decide which one is good fuel or which one is better fuel. Not good, we can say better fuel. Okay, so you can say delta Hc upon molar mass. Like that you can find out. Okay, so question will practice. Enthalpy of formation CH4 minus 80 kilojoule per mole, CO2 minus 400 kilojoule per mole, H2O liquid, remaining are gases, you know, minus 300 kilojoule per mole. Okay, calculate the amount of heat involved by burning 1 centimeter cube of methane under normal condition. So equation is given: CH4 plus 2 CO2 2 O2 CO2 gas plus 2 H2O liquid. Calculate amount of heat involved by burning 1 centimeter, not 1 meter cube of methane under normal condition. Heat of combustion. What they are asking? Heat of combustion. So check it, children, how it will be done. For this, enthalpy of reaction is equal to Hp minus Hr, reactant. So here product is what? CO2. So minus 400 plus 2 into minus 300 minus 80 minus plus 0. So here enthalpy of combustion will be minus 920 kilojoule, because here 1 mole only you are using, so that enthalpy of reaction will be enthalpy of combustion. That's it, but it is not a solution. So here 1 liter is equal to what? 10 की power minus 3 meter cube. So 1 meter cube is equal to what? 920 kilojoule upon 22.4 into 10 की power minus 3. That value you have to solve and you will find the answer. Normal condition means what? It's a standard condition, standard temperature and pressure. So that is for complete, and for 1 centimeter cube that value will come. See, so listen, means 1 mole CH4 produce 920 kilojoule energy. So 22.4 liter CH4, 1 mole is what? In the case of gas, 22.4 liter minus 920 kilojoule. So 22.4 into 10 की power minus 3 meter cube CH4 will produce how much? That liter we have converted into minus 920 kilojoule. Then for 1 this value will come. That is the unitary method. So some more enthalpy are given that we will discuss, because today we will finish the enthalpy concept. Like enthalpy of phase change. Enthalpy of phase change. Enthalpy of phase change, like enthalpy of fusion. Enthalpy of fusion means any liquid is converted into solid state. So here enthalpy of reaction is called enthalpy of fusion. What is called enthalpy of reaction is enthalpy of fusion for 1 mole. Okay, 1 mole liquid. Like H2O is given in liquid state, it will be converted into solid state. When it will be converted? By the freezing. Remember, freezing. For 1 mole it is converted into ice, and delta H is equal to minus 1.4 kilocalorie. So that value is your enthalpy of fusion. So that is delta H for fusion. Fusion in which case? Fusion in which case? Melting of ice. Sorry, fusion in which case? Water is converted into the ice. Vice versa, if H2O ice is given, it is converted into H2O liquid. What it's called? Melting. So fusion will be both cases, freezing or melting. So here delta H is equal to plus 1.4 kilocalorie. It will absorb energy from the atmosphere. So here that is fusion. That is also fusion in the case of melting. That is fusion in the case of freezing. Okay. Like second is enthalpy of vaporization. Like water into the water vapor. So what this process? Its process is boiling. So here H2O liquid to H2O gas, and delta H is given plus 10.5 kilojoule per mole. So here delta H for vaporization is equal to plus 10.5 kilojoule or kilocalorie. Similarly, H2O gas is converted into H2O liquid. How it will be converted? By condensation. And delta H is equal to minus 10.5 kilocalorie. So here that is condensation, enthalpy of condensation, enthalpy of vaporization in the case of condensation. Similarly, enthalpy of sublimation. So almost lecture is finished, and the third number is enthalpy of sublimation, solid to directly vapor. 1 mole of solid is converted into the vapor. So first it is converted into a liquid, then vapor state. So enthalpy of sublimation is equal to enthalpy of fusion in the case of melting, solid melted into liquid, then liquid vaporized. So minus enthalpy of vaporization in the case of boiling. So that's it about the enthalpy of phase change, children. So this topic is almost completed. Thank you, and later next video will be on what? Hess law. Next video on Hess law. Okay, so wait for the video, watch the video and subscribe the channel.